Hello. Hello. Hello, Varun. Is it audible? All right. Good afternoon. Good afternoon, everyone. I am Manu Srivastav, and today we are going to learn about Docker. So let's start. Today's agenda will be we are going to see what is Docker, what is virtualization, containerization, the difference between containerization and virtualization, what is going behind Docker, its architecture, how we can install Docker on our system, how we can spin up a container using the Docker image, and what are the different types of commands which we have on Docker. So let's start. So what is a Docker? A Docker is a set of platform as a service product that use operating system level virtualization to deliver software in packages called container. Containers are isolated from one another and bundle their own software, which have their own libraries and configuration file. They can communicate with each other through well-defined channels. So using Docker, we can create our own containers. So let's see what is the motto of Docker. If you go to the Docker's website, you will see they have their motto in 3 words. That is build, ship, and run. Build stands for Docker allows you to compose your application from microservices without worrying about inconsistencies between development and production environments, and without locking into any platform or language. So Docker allows you to create your application without thinking of any platform or any language. With any language or in any platform, you can create and build your Docker application. Second word we have is ship. Dockers let you design the entire cycle of application development, testing, and distribution, and manage it with a consistent user interface. On run, Docker offers you the ability to deploy scalable services securely and reliably on a wide variety of platforms. So let us see what is virtualization. On this diagram, you can see we have a host operating system. At the top of host operating system, we have hypervisor. At the top of hypervisor, we can create our virtual machines. In this diagram, you can see we have 3 virtual machines. Inside one virtual machine, we need to install a operating system that we called as guest operating system. It can be any operating system from Linux, Mac, Windows, CentOS, anything. At the top of operating system inside the virtual machine, we install our dependencies. Dependencies can be any language on which we want to create our application. Then we have our application. So, using virtualization on one operating system, we can run multiple operating systems, and that can have multiple applications running. So on virtualization, we have hypervisor which help us to create virtual machines. The benefit of using virtualization or containerization is that we can utilize our server resources efficiently. So let's see what is containerization. So you have seen on the previous diagram, we have hypervisor, but when we go for containerization, we don't have hypervisor, we have Docker engine. So at the bottom we have infrastructure, it can be our hardwares. At the top of infrastructure we have host operating system. On the top of host operating system we have Docker or any container engine. So at the top of container engine we can have multiple sets of containers running. So containerization is an OS level virtualization method used to deploy and run distributed applications without launching an entire virtual machine for each application. So let's see the difference between virtual machine and containers. On left hand side you can see you have an architecture of virtual machine or virtualization. On right hand side you have containers. If you see on the virtual side, on the left side on virtual machine, you have physical server, host operating system. Host operating system can be anything, but on Docker side, host operating system must be Linux. On virtual machines, we have hypervisor. Hypervisor can be a virtual machine where VMware, Hyper-V, or any other software which supports hypervisor. On container side, we have Docker, which is a container engine. At the top of Docker, we can run multiple containers containing dependencies and software application. Okay, so let's see Docker architecture. Here we have a Docker client. A Docker client interacts with Docker daemon. Docker daemon is sitting on operating system. We have Docker registry from where we can push and pull the Docker images. Docker daemon will help us to create Docker container using Docker images. So in this diagram, it is more clear how the Docker system works. On the client side, client gives a command docker build. So this command goes into Docker daemon. Docker daemon, which is there inside Docker host, will create a container from the Docker image. If the image is not present locally on the host operating system, it will pull the image from Docker registry. Let's see what are the terminologies we have on our Docker ecosystem. We have images, the blueprint of our application, which forms the basis of containers. So we can create Docker containers using Docker images. Containers created from Docker image and run the actual application. We create a container using docker run command. A list of running containers can be seen using the docker ps command. What is Docker daemon? The background service running on the host that manages building, running, and distributing Docker containers. Daemon is the process that runs in the operating system to which clients talks to. What is Docker client? The command line tool that allows the user to interact with the daemon. More generally, there can be other forms of client too, such as Kitematic, which provides a GUI to the users. We have another word, Docker Hub. Docker Hub is a registry of Docker images. You can think of the registry as a directory of all available Docker images. If required, one can host their own Docker registries and can use them for pulling images. Now you're familiar with the Docker specific jargons which we have on our Docker ecosystem. So for installing Docker, you need to go to docker.com. Based on your operating system, you can download. Here I am using Mac operating system, so I am downloading Docker Desktop for Mac. If you are using Windows, then you can go for Docker Desktop for Windows. So on this diagram, you can see a client is connecting with daemon, daemon is connecting with registry and images and container. Let's see the Docker container lifecycle. It starts from when we write a command docker build or docker run, it creates a Docker container. A Docker container can go into multiple phases, like it have a running state, a paused state, stopped state, or killed state. We can pause our running Docker container. We can restart and stop using Docker commands. At the end, when we are not using our Docker container, we can just kill the Docker container. So let's see how you can host your application on Docker container. In this diagram, you can see we have written on left hand side docker run -p 80:5000 my web server. So docker run is a command which will start a web server using my web server docker image, and it will map the port numbers. The first port number 80 is the host port number. The second port number 5000 is the Docker container port number. On right hand side, you can see the client is interacting with port number 80. This port number 80 is mapped with the 5000 port number of Docker container. So this is how the ingress network work in Docker. We can map our ports, we can map our ports number from Docker to our host operating system port number. Let's see tools of container orchestration. When we are running multiple Docker containers, we need some kind of container orchestration tool which will help us to run, scale, and manage our Dockers. So for that, we have different tools provided from Amazon to Docker to Google. So on cloud, Amazon AWS, we have a service called ECS, Elastic Container Service. On Microsoft Cloud Azure, we have Azure Container Service. Docker also provides its own tool for container orchestration, which is called Docker Swarm. Docker Swarm is an open source tool backed by Docker. Google also have their own container orchestration tool that is called Kubernetes. Kubernetes is also an open source tool which can be used for managing hundreds and thousands of Docker containers. Core OS Fleet, Mesosphere, Marathon, Cloud Foundry are the other tools of container orchestration. The most famous is the Kubernetes. If you are if you want to implement orchestration on production grade on production, then you should go for Kubernetes. And if you have less number of Docker containers ranging from 10 to 50, 10 to 100, you can go for Docker Swarm. So let's see Docker Swarm. On Docker Swarm, we have a Docker client. A Docker client connects with Swarm Manager. On Swarm Manager, we can have primary or secondary Swarm managers which are connected with Swarm nodes. Each Swarm node have its own Docker daemon and its own containers. So let's see what is inside a Docker engine. A Docker engine contains different orchestration components like distributed store, load balancing, service discovery, TLS, certificate authority, swarm mode worker, swarm mode manager. A container have its own networking, volume, plugins, and container runtime. So let's see what is container network model. Container network model CNM, which formalizes the steps required to provide networking for containers while providing an abstraction that can be used to support multiple network drivers. In this diagram, you can see we have at the bottom network infrastructure, at the top we have network drivers, IP AM driver, at the top we have Docker engine, top of Docker engine we have a separate network layer for containers. By default on Dockers we have three kinds of default network. First is bridge network, second is host, and third is none. So by default, all the containers can communicate using bridge network. When we create a container, they have their, their own IPs. Each container have its unique IP and two containers can communicate using their IPs within the network. By default, all the containers are connected using bridge network. We can create our own custom bridge network on Docker. Using the command docker network create --drive equal to bridge and your custom network name. So let's see some of the Docker's commands which will help us to use Docker. So let's see how we can create or build our Docker container. To build the image from Docker file, we have docker build -t. Hyphen, -t is for giving a tag name. So on the first command, you can see we are creating a Docker using the docker build command. On the next command, you can see docker images. This command is used for listing all the images that we have locally stored on our host operating system. For deleting and docker image, we can write the command as docker rmi. RMI stands for remove image, and appline colon 3.4 it is the image name. For running a Docker, we have docker run --name, container name, docker image name. We can also use flags such as -d to detach container on start, -rm remove container once it stops, -p publish host IP and host port to the container ports, -v define and share volumes across container, --v read only sets it to read only permission. Let's see the set of commands which can be used for cleaning up our Docker images and containers. First command we have here as Docker image prune. It is used for cleaning up unused images. Docker image prune-a is for removing image which are not used in containers. Docker system prune is used for pruning the entire system. Docker swarm leave is to leave the swarm. Docker stack rm stack name, it's for removing a particular swarm stack. To kill all running containers, we can write docker command as docker kill dollar. On bracket we can write docker ps hyphen q. So this will kill all our running docker containers. Docker rm dollar inside parentheses docker ps hyphen a hyphen q. This will delete all stopped containers. Docker rami dollar docker images hyphen q. This will delete all images. So let's see what are the commands which we can use for orchestration. Docker swarm init. This command is used for initializing swarm mode and listen to a specific interface. Docker swarm join hyphen hyphen token. This command is used for joining an existing swarm as manager node. Docker swarm join token worker token. This command is used to join a swarm as a worker node. As you know, for Docker orchestration, we have multiple tools, and Docker Swarm is an orchestration tool which is provided by Docker itself. So when we create multiple containers, we can manage it using Docker Swarm. In that we have a manager node and a worker node. So these commands will help us to manage our Docker swarms. Docker node ls will give us the list of all nodes in the swarm. Docker service create replicas 3 port number 8080 name of our web application. So using Docker Swarm, we can also do scaling of our web application. If you want to increase the number of worker nodes, we can just write a command as Docker service create hyphen hyphen replicas and give the number of replicas you want to deploy. Docker service ls, it will list all the services running in the swarm. Docker service is scale web equal to 5 or any number. This command will help us to scale our service. Docker service pswave will help us to list all the tasks of a service. Let's see few commands which will help us to ship our Docker container. When we want to pull some image from Docker Hub or any Docker repository or registry, we can write docker pull and the name of the image. Here we are pulling Alpine 3.4 from Docker Hub. When you don't have this image present on your host operating system, you can pull it from Docker repository using the command docker pull image name. Suppose you want to create your own image and you want to store that image on Docker Hub repository. Then you need to create an account on dockerhub.com. Then on your own operating system where you have your Docker image ready, you just need to run Docker login. It will ask you for your username and password. Then you need to tag your Docker image using Docker tag name of the image space where you want to store your Docker image. Suppose you want to store your Docker image on Docker Hub, then on my repo you can write your Docker Hub username slash name of your image colon tag name. Tag name defines the version of your image. You can upload multiple versions of your images and give them different tag names or version names. To push that image into Docker Hub, we have a command docker push my repo slash the name of the image and the tag name. So let's see some important terms on Docker. We have layer, which is read-only files to provision the system. Image, a read-only layer that is base of the image. Container is a runnable instance of image. Registry or hub is the central place where images live. Docker machine is a virtual machine to run Docker containers. Docker Compose is a virtual machine to run multiple containers as a system. On services, we have different commands on Docker like Docker service ls. This will list all the services running in the system. Docker stack services, your stack name will give you all the running services. Docker service logs, stack name, service name will give you the logs of your running stack service. Docker service scale, stack name, stack service name equal to replicas is for scaling the number of nodes which are running inside your Docker orchestration tool. So how we can interact within a container? When you're running a Docker container, you can interact it by using the command docker exe -ti. This is for interactive mode. Give the container name and the command you want to run. If you want to see the logs of your running Docker container, you can write docker logs hyphen ft and the container name. If you want to save a running container as an image, then you can write the command as docker commit -m, give the commit message, -a, give the author name, give the container name. When you have created your account on Docker Hub, you will get a username. You can write that username here, slash the name of the image you want to give, colon the tag. Tag defines the version number of your image. By default, the tag is taken as latest. So let's have a look at the cheat sheet. What are the commands we have seen? Have a look, then we then we can go for a demo. Okay, Rohit. So you're asking what is a detach? Okay, when we run our Docker, we have a command to run our Docker as docker run -d. When we write -d and we run our Docker image, if we close our terminal also, the Docker will not stop running. So let's go for a demo. So it will give you more clarification what I'm talking about. First of all, you need to download the Docker from docker.com. I have already downloaded Docker on my system. So when I type the command as docker, so you can see it gives me a help documentation here. So here we have all kinds of commands which we can use on Docker. We have attach, build, commit, copy, create, and so on. Okay, so let me give you example for Docker run. So Docker run appline, as appline is one image name. I don't have that image on my system. Whenever we run Docker run, whenever we type the command docker run and our image name, It will first check locally on our system. If the image is not found, then it will go and fetch it from the Docker Hub. Suppose I want to download or run a Nginx server container on my system, then I need to write docker run nginx. On the first line, it will check for that image on my local system. When it's not found, it will go to the Docker Hub and fetch the latest version of the Nginx and download it or pull it into my system. So on the status you can see downloaded newer image for Nginx latest. Okay, I think you can see the commands now. Okay, so now you have seen how we can download a image from Docker Hub. Docker Hub is a repository from where you can download all kinds of images of different applications or operating systems. Here you can see I am on Docker Hub website, and if I want to search for Nginx, so Docker have official image of Nginx. So this is the command you can see here, docker pull Nginx. When I run this command on my terminal, it will download the Nginx Docker image into my local system. So let's see how we can spin up this image into a Docker container. By the Docker pull, I have downloaded the image of Nginx. Now, by docker run command, I want to spin up a container using the Nginx image. So okay, on this command you can see I am trying to spin up a Docker container using the command docker run. On name, I can give any name of my Nginx server. I can give it my web app. -D is for detached mode. -P is for defining the port numbers. We have two port numbers here. The first port number is for host operating system by which we can access the Nginx. I can give it as 8898. 80 is the internal container port number, and Nginx is the container name, image name. So let's run it. If you want to check how many containers are running, we have a command docker ps. So here you can see I have multiple Docker images running on my system. You can also see Nginx image here. So when I go to port number 8898, you can see I have a welcome page for Nginx. So we have seen how we can download any application from Docker Hub, how we can run it and map it with our custom port number, and to list the running Docker containers, we have docker ps command. So I think up to here, everything should be clear. Okay, so Hitesh have one question, which are available in Docker Hub, or I would say repository. Yeah, Hitesh, I understand. Here I'm using two laptops, so it's become difficult for me to see both the laptops simultaneously. On from one laptop, I am sharing my screen, and on second, I have a YouTube running on. Oh, anyways, I will try to make this session more interactive, as now we have started our demo. Okay, so Docker Hub is a repository where we can upload our own image, or we can download the images which are already uploaded on Docker Hub. So this is how the Docker Hub looks like. You can create your own account on Docker Hub, and when you create your own account on Docker Hub, you can upload your own images. also here. So I will show you. When you go to the repositories on Docker Hub, you can see these are the images which I have uploaded into Docker Hub. Like this we have, which I have created 6 hours before ago. And if I click this one, you can see it's a public image. On Docker Hub, you can create both a public or a private image. On text, you can see I have only one, that is the latest. By default, it takes the latest, or I can give some kind of version name to it. So here we can create a build which will test that our image is working properly or not. We can connect it with the GitHub or Bitbucket. We have a facility of calibrators where other person can also push into your repository. We have webhooks, then setting. Um, there you can see I have a free account, so I can only host one private repository, and multiple public repositories I can host. Here is a button for delete repository. So on repositories, you have all the images, your own created images which you have uploaded on Docker Hub. So let's see how you can create your own Docker image or custom Docker image and publish it into Docker Hub. So before that, you need to first go to Docker Hub and create your own account. It will give you a username. You have to set username and a password in this. Okay, then go to your system terminal and type docker login. It will ask for username and password. As I have already logged in, it's telling me login succeeded. Let me log out from here. So docker logout is a command to log out from the terminal. Okay, again I am going to log in using docker login. So you can see now I have to give my username, Manu Srivastava. Then I need to give my password. Okay, I have written my password, then enter. So now it's login succeeded. Okay, so let me give you a demo how we can push our own image into Docker Hub. First, let's see how many images we have. So you can see we have multiple images here. So let me first clear this all images. So for that we have a command. Alright, so suppose I want to upload an image of Nginx. So I should write, first I need to tag docker tag the image name which I have Nginx, space my username, and what image name I want to give. I want to give Nginx and the latest as a tag name. Now docker push my username slash. Okay, now you can see I have created my own image using the Nginx image and I have tagged it. Now I am pushing that image into my own repository on Docker Hub. So the image has been pushed. So let me go into my Docker Hub account on repositories. You can see we have Nginx here, which has been uploaded a few seconds ago. So for this session, we are at the end of this session and we have so many things we learned so many things about Docker, the commands, the orchestration, how we can use Docker Hub, how we can create our own image and upload it into Docker Hub. So by this, I think you have got a fair knowledge of Docker. For more in-depth knowledge of Docker, we will set another session. For this time, I think we are okay with this. And if you have any kind of a question, you can ask on chat box. As we are running out of time, so quickly I can give answer of 2-3 questions, then we can close this session. So I'm not getting any questions on chat box, so I think we can wrap up this session. Thank you for attending this live webinar session on Docker Hub. Thank you for your time. Bye bye.